All right, everyone, I see that the recording has started, so we'll go ahead and get into it. My name is Cameron Presley. Welcome to Philly Code Camp 2022. And if you're in the right spot, you're here to learn how to have code reviews that your developers actually want. Before we get too deep into everything, I just want to let you all know that the slides are already live, and you can find that information at the following URL, bit.ly philly-code-review. So the way I typically present is a little bit more interactive. So at certain spots, feel free to type something in the chat or come off mute, both of which will be fine. And we'll go ahead and get into it. So the first question I've got for you all is, what does code review mean to you? What comes to mind?
You got a mic here? Can you hear me?
Yeah, we can hear you. Bill, what you got?
Oh, okay. Well, a code review is just kind of at least the code reviews that I have seen have just been code developers getting together in the room and somebody going over their application and kind of people are open to make comments and coach them and just have conversations and stuff. It's everybody. It's not just for the guy. At least the ones I've had. It's not just for the guy doing the code. It's for the people in the room as well, because everybody gets a chance to learn something from it.
Okay. Yeah, that's. I'm really glad that it seems to have a positive connotation with you. So that's awesome, Bill. Thanks. Erwin in the chat's got code that's compliant with the team standards. When I think of code reviews, especially, let's say, not great ones, because I've worked at places where it weren't, they usually fell under one of two patterns. One of the more common anti-patterns is the looks good to me code review, right? So you've submitted a PR, it has tons of changes, right? Maybe dozens of files, hundreds or thousands of lines of change, and someone spent 5-10 minutes at it and essentially just said, yeah, looks good to me, go ahead and merge it in. And that's not super great because that makes it feel like it was just kind of got rubber stamped. And if you're having a lot of code reviews where people are just saying looks good, merge it in, and they're not really reviewing or reading it, that's a really big waste of time. So that's one anti-pattern I've seen. Another anti-pattern I've seen is where there's a lot of back and forth on just something simple. And you can see tons of comments that start with something like, well, what about this or this? Did you think about this other thing? What are your thoughts on this? And then all of a sudden, that simple 4-line change that you thought you could get in an afternoon, not a big deal, turns into one of these things where you're having to scrum with the other members of your team to try to figure out, is this the right thing to do? Everyone in their, everyone and their grandma has some type of opinion, and it's just super frustrating. And then once you get through all of it and everyone realizes like, yep, your changes are fine, you kind of feel like this, right? You kind of feel tired and exhausted, and this should not have been this hard. And that also kind of feels like a waste of time. So let's go back to the roots of code review, and Bill's kind of hinting on it a little bit earlier, right? So I'll do like we do in any good tech presentation. We'll go ahead and quote some Wikipedia, but a code review is a systematic examination of computer source code. It's intended to find mistakes overlooked in the initial development phase, improving the overall quality of software. So what's really interesting to me about code review is that I've definitely talked to companies where they kind of look at code review as a bad thing, or I've talked with engineers and they get nervous that code review is kind of, a punishment or it's a bad thing. But in reality, there are tons of professions that do some flavor of a code review. If you talk to architects, they have a thing of peer review too. They're called red line reviews. And that's where they'll actually sit down with a red marker, red pen, and actually mark up blueprints and designs and such. Other engineers have peer reviews. Doctors have this too. They're known as consultations. If you think it's only for white collar work, those who do welding actually do welding review where their welds are x-rayed and critiqued by others to make sure it's actually up to standards. If you think it's only in the professional world, high school students had this too if you ever took an English course because you had one of your peers review what you've written. Newspapers do it too as copy editing. So this concept of having your work critiqued by others really shouldn't be a foreign concept. It should be something that we're okay with. But I'm going to open it up to the group a little bit, right? one of the main intents of a code review is that it's to find mistakes, right? And you want to find those mistakes a little bit earlier than later. But why do you think it's important to find these bugs sooner, to find these mistakes earlier in the process? Anyone want to take a guess?
The earlier you find mistakes, the quicker, easier, cheaper it is to repair them.
Oh, absolutely. It makes me feel like that maybe you're a team lead or a manager of something of that ilk, because you actually mentioned the money part. Yeah, bugs cost more later they're found, right? Like it's just more expensive to fix that way. And contrary to popular belief, your company, whoever you work for, wants to deliver like working product, obviously, but they also want to do it as cheap as possible, right? And there's always that kind of back and forth. But the question then becomes, well, okay, Cameron, they're more expensive the later they're found, but how much more expensive? Can you put some numbers on it? And actually, I kind of can. For those of you who may be aware of it, Steve McConnell wrote a book, Code Complete Second Edition. It's 700 or 800 plus pages of really good engineering principles and practices. And it's one of the few books I've found in our industry that covers both the industry and academia in one convenient tome. And in that, he actually cites a couple of studies that talk about, how expensive are bugs. And there's a chart that I've copied here that gives you some rough ideas of how more expensive something is to fix. So the way to read the chart is, if we find a bug during requirements gathering, and let's say we fix it, or we discover it and fix it during construction, it costs us 5 to 10 times more than if we had just found it in requirements. And that kind of makes sense, right? If I'm talking to a product owner or the business about a requirement, they say something, I go, no, that doesn't make a whole lot of sense. Can you talk to me more about it? And then we realize there was a bug there. I just update a doc, maybe update a story. If we don't discover that discrepancy until we're actually writing the code, though, that could be fun, because depending on how you've designed your system, that could be a non-trivial fix. And as you can see, and for this presentation today, we're going to be focusing more on the construction and the construction row, that bottom row. And the reason why I'm doing that is because I'm going to assume that you've got perfect requirements all the time, which I know is not always true, but let's pretend that it was, and that your architecture decisions are always pristine, they're always perfect, what have you. You can still find that if you introduce a bug at construction time and you don't really find it until after you've released it, it could be 10 to 25 times more expensive. And that number seemed weird to me until I really thought about it and go, well, yeah, that totally makes sense, right? Because you've shipped the bug. Now you've got customers or clients calling in, reporting the issue, or someone's complaining about it, which means you've got to take the time to deal with that. You then have to write up a story to say, hey, there's this thing we got to fix. There's going to be meetings to talk about it. It's going to get estimated, get assigned, get fixed, get tested, get released, all those things once again. And that can take a non-trivial amount of time and money and effort. So this kind of started making some sense to me as I was thinking about it. But I was curious how other companies thought about this. And so Steve McConnell actually has some excerpts from that same book that I want to share with you all. So one thing that IBM found was that when they were doing code reviews, for each hour they spent reviewing their own code, it actually saved them about 100 hours worth of related work. So assuming, $50 an hour, that means for every $50 they invested into code reviews, they saved $5,000. That is a fantastic return on investment. I wish I had that right now. Let's keep going, though. Another company, Raytheon, they found that when they were doing projects, 40% of the entire project cost was due to rework, bug fixes, missed requirements, things like that. They found that once they introduced code review, it actually reduced their total cost from 40% to 20%. So what that means is for $1 million project, instead of spending $400,000 on bug fixes, they only spent $200,000. For those of you in more individual contributor roles, go to your manager or team lead and ask if they're cool reducing their cost by 20% of a project, or potentially 50%. most of them are going to be pretty excited about that. So we've talked a little bit about, you know, code reviews at the professional level, and don't get mistaken here. We are professionals, right? Part of that is ensuring that we are doing right by our clients, by our customers, by our employers. But putting our professionalism to the side for a moment, what do code reviews mean for us, mean for me, mean for you? I don't know about y'all, but when I got started, I didn't know what I was doing, right? When we get started in software engineering, we sometimes know how to write code, right? We know what an if statement is, maybe we know what loops are, we know classes, objects, but we really don't know how to compose these things and to build really good software or actually anything sustainable. And we need that time to nurture, we need that time to grow. And code reviews actually provide a really cheap and efficient way of leveling up not only yourself, but those around you. I think Bill was mentioning earlier that when they grab a bunch of engineers and put them in the room, that everyone has a way to level up. Everyone is getting better. This is a really cheap and efficient way of doing so. I'm also going to kind of talk selfishly a little bit about your career trajectories and your abilities to actually get a job. Let's say that you had a decision to hire one of two engineers, right? Engineer A and Engineer B. Engineer A has been doing this for about 5 years, but those 5 years of experience has been essentially doing the same exact things over and over and over again. And they've not really learned anything new. They've not really practiced any new skills, no new techniques. They've pretty much been doing the exact same things today as they did when they first started 5 years ago. Engineer B, on the other hand, only has 2 years of experience. But during those 2 years, they've worked on a mix of different projects. They've worked on a mix of different tasks. And because of such, they've learned a lot of skills and techniques. Between the two, which one would you much rather bring onto your team? Most likely Engineer B, right? Because they have that experience. Even though they don't have as many years, they've seen a lot of different things. That means they have a lot of different perspectives that they can bring to your team, which is going to make them a lot more beneficial. Also, it kind of shows that they know how to learn things, which as an engineer, a track record of learning stuff on the fly is kind of important. So much so, in fact, that if we kind of take a look at this chart, we'll see that even though maybe Engineer B was kind of a little bit on the lower side, over time, because they've been doing so much more leveling up, they'll actually kind of overtake Developer A at some point. So that's kind of one of the reasons why I think it's really important for us to be doing this. And excuse me. And there's some other things to keep in mind too here is kind of leveling up in your career. And it's kind of a rough subject, but even career safety, right? Let's talk about that a little bit. The pandemic has been a little bit eye-opening for some people, right? Because all of a sudden their job that they thought had was maybe not so secure. I argue that leveling up your skills is a good way to make sure you have a job or the ability to get a job. So by being valuable, that helps you keep your current role. And then being employable means that if you need to switch jobs, you can do it pretty easily. Now I know that finding a job as an engineer typically isn't too hard, but I would much rather be able to be choosy and have a choice when finding a role if I needed to versus crap, I'm out of work, I need to take the first thing that I can. So being valuable, it means you know more skills and techniques, right? When companies have to do layoffs or they have to downsize, they're not going to let go of the people that know where all the bodies are buried, knows how all the stuff works. So knowing those skills and techniques is really important. In addition, if you're able to do code reviews, that typically means you know how to work well with others, you know how to communicate a little bit more effectively. And as an engineer, that's a really critical skill to be able to converse well with others. So be able to prove that through code reviews, and you'll see why later on in the presentation, kind of a big deal here. In addition, if you're seeing in all these code reviews and you're learning more about how things are running, that typically means that you know the problem domain and you know how things have to sit, how things hang. That's a huge plus for you because once again, if a company has to downsize, they're not going to let go of the people who actually know how the things run around here. They're not going to do it, right? It's too much risk, not enough reward. But let's say you unfortunately do find yourself being downsized or you need to change roles for whatever other reason. It's really easy to get a job when you have demonstrable skills and techniques that you can talk about. Being able to talk about your previous experiences through code, because you've done code reviews, it's been critiqued, it's been reviewed, can help you level up that way. In addition, I found it's really easy to teach people technology. It's a lot harder to teach people like people skills, right? And whether we like it or not, you have to be able to work and interact with others. Otherwise, you're not going to have a great time in this career, right? Your career growth will be limited. Some of the techniques I'm going to show you today, so the trick is, even though the presentation is how to have effective code reviews, it's essentially how do you talk well with others, and you'll see that in a minute. So at this point, I've hopefully set some context of why I think code reviews are important and why we should be doing them. But we haven't gotten into how do we have good ones, right? We've talked a little bit about what bad ones look like. So let's dive into that. Over this next section of the presentation, I'm going to talk about common anti-patterns I've seen at other companies and some ways to combat them. And first and foremost, the big thing I want us to stop doing is let's not submit a novel to review. This kind of goes back to the whole don't submit a pull request or some changes that I need to make a pot of coffee, pull up a seat, and get cozy for the next day, right? That's not helpful. I can't do anything with that. Well, and you come to me and say, well, Cameron, cool, I understand not to submit 5,000 changed files, but how much code is too much? And I'm glad you asked that. So back in 2000 and, oh goodness, I think it was 11. I think it's been about that far. IBM partnered up with SmartBear and Cisco to actually figure out what are some good best practices to do code review. And they actually published it as the 11 best practices for code review. They continue to do this study every year. SmartBear is the one that kind of runs with it. So you can always find kind of like a state of the union, if you will, of code reviews. But when they did this initial one, it involved 2,500 code reviews with 50 engineers over 3 million lines of code and Cisco systems. So a non-trivial amount of code, a non-trivial amount of stuff, but still one data point. So do take that with a grain of salt. And what they found were the following. So they found that essentially as the lines of code under review increased, the ability to find bugs dropped dramatically. And what they specifically found was at this inflection point of around 200 lines, and then again at 400 lines. So the essential lesson learned here is that once you get past that 400, 500 lines of code, you can't keep track of it. Bugs just slip through. Your ability to find things through manual review just start dropping dramatically. I will put a caveat in here and say that this is probably 500 lines of written code versus generated code. So for those of you who do a lot of desktop development, right, any of the generated code there in the designer files probably doesn't make as much sense. But I actually found it fascinating that 500 lines, because to me that didn't seem to be a whole lot of code, right? I look at 500 lines PRs quite often. But they also came up with some additional things to keep in mind too when doing code reviews. They recommended no faster than 500 lines of code an hour. And they also recommended to not do more than an hour of code review at a time. I found that last one to be really interesting because you're essentially saying you can review code for an hour, take a break, come back for an hour, take a break. I don't know about you all, but how often are you all getting an hour or more of distraction free? How often does that happen? Probably not often, right? And I started thinking about like hour seems to be a really interesting point. And then it occurred to me, well, at least when I was in high school, when I took college, my classes were roughly around an hour long. So I'm wondering if it was more of an attention span thing. But needless to say, right, that's some of the best practices here they're recommending. No more than 500 lines of code in an hour, and you probably want to take a break every hour or so. What do we do then, right? Because sometimes we're working on a really big feature or a really big story, and by whatever the nature of the work, it's going to be massive. Well, break it down in smaller pieces. So, and you've got one of two ways you can do this, right? So if you're going to be breaking down things into smaller pieces, you can either break down a large story into smaller items, so you've got more stories to work with, or, and I've done this a couple of times, you can have a branch of branches situation. And we'll talk a little bit more about each. So when you're breaking down stories, you can do something known which is called vertical slicing. So let's say I am creating a brand new screen in an app, right? Instead of saying, well, here is a story to do the entire screen. So that's the UI, that's the backend, that's the API, that's the database. I could instead do vertical slicing and go, okay, well, this very thin slice handles showing just a single field that maybe talks to a dummy endpoint for right now, and that dummy endpoint doesn't do anything with the database, but I can at least get something to work. That's really helpful because I can easily code review that to make sure that's working correctly, and that's not as much code to review. And then you keep building it up over time. The other way you could have sliced that same story is known as horizontal slicing, and that would have been, well, I'm going to build out everything in the database first, and then once that's solid, build out everything in the API, and then once that's solid, build out everything in the front end. You could do it that way because it still breaks it down. I would argue that you're probably not as delivering as much value as vertical slicing in that scenario, but the idea is you're still taking this big story and still breaking it down into smaller chunks, which means I can focus on a more, I don't have to focus on as many things, right? I can focus on just one section. However, let's say that for whatever reason, it can't happen that way, right? You've got a customer or client who doesn't want the work, doesn't want the code delivered that way, or there's just not a really great way to naturally slice it. You can use a branch of branches technique. And what this usually implies is you create a branch from the trunk. You can call it work in progress. And then what you do is you create a feature branch from that work in progress that handles each of the smaller items. And then you're reviewing those smaller branches, merging it back into work in progress. And once all the small stories are done to that work in progress, you can merge that branch back into the trunk. I don't like this approach because that means you have long-lived running branches, and that has its own set of problems. But for situations where you can't really break it down to smaller stories, you can still do it this way. And if you all want to chat a little more about these techniques at the end of the presentation, that's fine too. There's some other approaches that could work, but these are the two I usually recommend for those trying to start out with breaking down large amounts of work. The other piece of advice I give is make sure when you're providing feedback, you give some context behind it. It's pretty natural that when you review someone's code for you to go, that's not how I would have done it, or what is this code supposed to do? Or in some rare cases, you're just like, what in the world were they thinking? This entire approach is bad. I need to take their keyboard away from them because they just don't know what they're doing. One thing I stress to engineers all the time, though, is when we're writing code, is the goal to have everyone code the solution the exact same way? No. The goal is to solve the problem, right? Your company, your client, your customer actually doesn't care what the code looks like. They don't care. I can assure you, your CEO, your CTO has never pulled down your code and said, I don't know if I like this ternary they've got. They literally don't care because no one cares. What they care about is the problem being solved. It's up to us, though, as professionals to make sure we are solving the problem correctly, right? And that's where code reviews come in. And to make sure we're solving correctly, that means we have to provide actual feedback. So telling someone that, hey, your code sucks doesn't help anybody. It might make you feel better, but it didn't really improve anything. So when giving code reviews, I typically like to frame my suggestions around context using when, what, and why. Let me show you. Here is some C# code, right? And it's getting some stuff from a database. Doesn't really matter. The part that's caught my attention, though, in this code review is this bit. It's caught my attention that there's some logic here that, hey, wait a minute, if there's nothing in the database, we're going to return null. And that seems bad because the return type of this method is a list. And we typically don't want to return null from lists. You would normally want to return an empty list. So my first thing is to yell at the engineer, hey, don't use nulls. But that's not helpful because what should they do instead? So what I really am capturing here is, hey, we probably don't want to return null when retrieving a list of records from the database and there aren't any. All right, cool, but why? When returning records from the database and there aren't any, we should return an empty list because, and that's the key word here, because all of the list methods work on an empty list and we don't have to introduce a whole lot of error handling code. And if we break this down, when this thing happens, when we're trying to return records from the database, we should do this because of this. Here's the why. Because I don't want to have to introduce a whole crap ton of error handling code if we don't have to. That's pretty cool. Right? What's really nice about giving feedback in this approach, or at least thinking about these things as we're phrasing it, is that we're actually going to have a conversation about that work with fellow engineers. Because here's what may happen. I'm just going to pick on someone on the chat. I'm reviewing David's code, and I'm like, David, we shouldn't be returning null because we're trying to return back a list. It should be empty. David could tell me, oh yeah, Cameron, I totally understand that. However, the front end actually treats nulls versus empty lists as very different. So I'm trying to capture that correctly. And that makes me go, oh, really? Interesting. Okay. And now David just taught me something, right? I've now learned something about our code base that for whatever reason, the front end is treating null and an empty list as different things. It does different behaviors. Oh, shoot. I didn't know that. Okay. But notice how we were able to have that conversation. And we were able to have that conversation because I framed, here's why we shouldn't be doing this. And I did it in such a way that I didn't say, you know, that engineer was stupid or didn't know what they were doing, or, oh my goodness, take the keyboard away, right? We were actually able to have a conversation because I treated them like a peer. And that's important when we're doing code reviews. That being said, as a code reviewer, the other thing to keep in mind is the person you're chatting with, make it nervous or be a little bit anxious. Especially for someone who's new, right? And new as in new to engineering or new as in new to this place they're working at, right? They want to make a great impression, and it can be a bit nerve-wracking to have maybe a senior engineer reviewing your work ready to take a fine-tooth comb across it, right? And in fact, this is so normal that Cyanide Happiness actually did a comic about it. So we'll read through it. So engineer 1 goes, man, my boss says I need to completely rewrite my code. Engineer 2 goes, it can't be that bad, surely. Here, read through this and highlight anything you think seems stupid. Sure. And then, man, engineer 2 is not happy, right? You can see that face starting to turn down, and what do? They highlight engineer 1's face because that's what he thought was stupid, right? That's not how we want to do this. But this is how sometimes we can feel. So realizing that this is a thing and we can address it appropriately by framing our context can actually be really helpful. So one thing I will do to kind of remove some of that anxiety is I'll reinforce this like joint ownership. We're in this together. And it's with this one simple trick. Instead of asking, hey, what should you do when there are no records in the database? Switch it up with we. What should we do? Right? The onus isn't on just the engineer who wrote the code on how to handle this, right? I'm here too. We can brainstorm. We can come up with some ideas. But I found that by just switching out you to we, it opens up that dialogue. It opens up that conversation to actually be a two-way street, which is what you're wanting when you're doing code reviews. And the reason why that's important is because not any one developer owns that code base. Even if it's just you right now, 6 months down the road, it could be you 6 months down the road who didn't touch the code originally, so you don't remember that stuff. But since not any one developer owns the code base, we need to at least make friends. We need to be able to chat with each other, right? This joint ownership. So, and that's kind of important, right? Because you may be looking at all this getting really frustrated, and you might be thinking all these things. So even though it might make you feel better to say this for loop is garbage, what in the world were you thinking? Take a minute and really think about what's causing the grief. A technique I'll use here is instead of saying this is garbage or what were you thinking, I'll admit some ignorance. Hey, I'm having issues understanding this code. Can you step me through? I'm a senior engineer. Hell, I've been doing this for over a decade now, but I'm not foolproof, right? I'm not omnipotent. So I may look at code and be like, I don't understand. Can you help me out? And one of two things could happen here. Maybe the engineer who wrote this code goes, you know what, Cameron's pretty good at what he does. And if he's having trouble following it, maybe this code isn't as clear or as simple as I thought it was. Maybe I need to refactor it. That's one thing that could happen. Here comes the other thing that could happen, though. Maybe I learned something. Maybe my problem is, oh yeah, I'm not familiar with some of that link you're using. Can you explain it through me? Yeah, sure. Link's pretty common. I can easily level you up in that. Oh, snap, right? Like now my own knowledge is being leveled up here. And that's happening because I literally asked the question, hey, I don't understand this. Can you just walk me through what it's trying to do? And to me, that's a really powerful technique. So I'm going to take a minute to pause and see if there's any questions in the chat or if anyone has any perspectives they want to share at this point. Okay. I understand it's a little bit late in the afternoon. It's all right. We'll keep moving then. So the other reason why it's kind of important that we have this shared understanding of code and we can do that by admitting ignorance is because there is a factor that we like to avoid. And some people call it the lottery factor. I knew it as the bus factor. And so what both of these factors are essentially how many people could be taken off the project before the project could fail. So a little bit of story time. At a previous job I was in, we were writing software for one of our clients, and the software had to be, it was a desktop application that was installed via some installer software. What that software was is not important. The important part is only one person knew how to build that installer. Me. It was me. I was the only one who knew how to do it. And there was a situation where I wasn't at work. I was taking care of some personal matters, and I got a phone call from my work saying, hey, Cameron, our client needs an emergency update. We've got the code fixed, but we don't know how to make the installer. We don't know how to ship it out. Can you help us? I had to step away from at a really inopportune time to go help them out on this. And the reason being is because we weren't doing code reviews at the time. And I hadn't done my due diligence on making sure people understood the code I was writing and how to solve some of these. And that project, the bus factor was one. It was me, right? If I ever left, that we had problems. I actually encourage you all to think about on your own projects, what's the bus factor, right? If two people, let's say one person won the lottery and left the project, how catastrophic is that? Right? You want a really high number, right? You would want the ability to be like, yeah, over half the team could leave the project and we'd still be okay. If not, you might want to start thinking about how to rectify that. And at this point, we've kind of talked about at a really high, level of emotionally, here's how we should talk to others and how we do these things. But I haven't really given you any tips yet. So let's talk about what I look for in a code review. Now, I'm going to preface this by saying this is what I look for. This is not an exhaustive list. This isn't what your list should be. This is just what catches my attention. When I read through code, these are the things I look for roughly in this order: correctness, readability, maintainability, and style. If the code's not doing what's supposed to be doing, the rest of it doesn't matter. If the code's working but I can't understand why it's working, we've got problems. If the code's working, I can understand why it's working, but making a simple change is going to take me 3 weeks, that's a problem. And then the last one, style, is essentially if the code works, I can understand it, I can easily maintain it, but someone did an array instead of a list. Okay, right? That's that's a stylistic thing. We can fix that. So when we talk about correctness, it's really our inputs handled correctly. And so that could be things like, are we getting the right answer? Are we handling things correctly? How about nulls, empty arrays, negative numbers? What about other interesting edge cases that we haven't talked about yet? Right, so I will typically go through like the whole machine of, well, if I set up these inputs, does this happen? If I set up these other inputs, does this happen? Right, and so kind of a contraption going on here, if you will. So not only do I check if it's working correctly, I also check if it fails, does it fail correctly? For example, does the app crash? Sometimes that's the right thing to do, funny enough. You rather the app crash than it takes some catastrophic effect. But sometimes, did the user get presented with a useful message? And what useful means is different things. For example, if I'm writing software that is used by other engineers and this piece of software I've written can't talk to a database, it's probably okay for me to tell the user, hey, I couldn't connect to that database, sorry. If I'm working on accounting software, on the other hand, I probably shouldn't be telling the user, hey, by the way, I can't reach to a database, sorry about that. Right? Sometimes correctness really truly is, are we failing and failing correctly for the right reasons? And when we do fail, are we presenting it appropriately? So those are some of the things I'm looking for in a code review. Readability, right? Kind of what world's going on here. The trick to readability, though, is there's no really one true metric. It's actually determined by your team. A team of senior engineers are going to write code in one way that's super readable to them, but may not be the most approachable thing to a team of mostly associate engineers. So what we've got to be careful of, and what I shoot for, is let's write clear code, not so much clever code. If you've got this really awesome plug-in modular system that is using reflection to self-new up its things and then automatically dynamically register itself in the version of control, that's cool if that's what's needed. But if it's only 2 modules and they're both hard-coded, why not just write that code out manually, right? So what I look for here is we should write code that's simple enough to solve the problem at hand. However, this does not mean that you code to the lowest denominator, right? You don't code to the weakest engineer on the team. You code to what's needed. And if that means you need to raise up the engineers on your team, cool, do that, right? Like, that's not a problem. Just make sure that we go through that workflow. And our general rough measurement you can do for readability, though, I always appreciate this comic, is the only valid measurement of code quality is the WTFs per minute. So good code only has a couple, bad code has a lot more. So I was looking for a nice little chuckle this afternoon. So at this point, you've written code that works. You've written code that is somewhat readable, but now let's talk about maintainability, be able to make changes to it. The cool thing is, for almost any project you'll work on, the code's always changing. It's always in flux because you're building new stuff to it. If you're working on a project and there's nothing new being built into it, the project may be dead, in which case you've got other problems, right? So when we're designing code, we want to design it in such a way that changes that sound easy should be easy, right? If someone's like, hey, Cameron, we need to make sure that this checkbox is checked by default. All right, cool. That should be a 10-minute fix. If I come back and say, man, we can do that, but it's going to take 4 days, we've probably architected something incorrectly there, right? And so some things that I'll do for maintainability is I'll check to see, are we following certain patterns and patterns or architectures? For example, if I'm working in a layered architecture, but then all of a sudden someone's doing some microservices stuff on the side, I may have a couple of raised eyebrows going like, oh, why are we doing that over there, right? If I see someone copying and pasting the same module in 20 different places, I may ask some really good questions about, hey, why are we copying and pasting that everywhere? Going back to the dynamic plugin architecture that's automatically registering an IOC, I'll ask, like, should we be doing that, right? So that's kind of what I'm looking for in the maintainability section. Last but not least, style. Does this code look like it should? Does the C# code look like a C# developer wrote it, or more like a Ruby engineer who was told to write C#? I will typically find this a lot for people learning a new language, so either associate engineers or people who've changed tech stacks altogether. And so what I'm looking for here is naming conventions, proper coding constructs, project structure, those types of things. If you've got a good linter, that will solve a majority of this, but sometimes you still need someone to kind of give that final inspection. Style guides are also really helpful. So, kind of use that as be. One thing that you all might find interesting is I've not really mentioned a tool yet, right? I've talked about general ideas and practices, but I've not said, you all should be using blank, or, oh man, you all should really try out blank. And the reason being is because there are so many tools out there, it'd be kind of irresponsible for me to recommend a set. So here's what I find is companies will buy tools and then they will force their engineers to use the tools for the process. And it's actually backwards. You need to do it the other way around. Take some time to figure out how do you do code reviews? Why should we be doing code reviews? Do that homework first and then find the tools that support your process. Your process dictates the tools, not the other way around. A good friend of mine, Jeff Mazeroff, has written a blog post on how to start code reviews, and he actually approaches it from that perspective of, oh, you're at a company and you've never done code reviews before. How would you even get started? It's listed as one of the resources for this presentation. Would highly recommend it. So looking at the clock, looks like we have enough time. So we're actually going to spend the next 10 minutes or so going through an example code review. And a little bit more in detail on how I approach it. So in this case, it's a bug fix. So when I'm leading through a code review, the first thing I'll start with is framing. What's the problem? And at this level, I'm going to focus more on the user interaction, and I'm going to describe what the problem is using domain terminology. So instead of going this way, which is clicking the submit button on the add item to order module causes a foreign key constraint violation in the database. All of those words could be technically true, but from a user perspective, I might as well have just written gibberish, right? This is total garbage. It doesn't really explain what the heck's going on or what the problem was. Hey, adding an item to my order causes an error when submitting the order for approval. Awesome. Makes a lot more sense. I know exactly how to reproduce it, and I actually know why this is a problem, right? Even though the two things are exactly the same, right, still describing the same problem, one's a lot closer to the user level, and as a code review, that's kind of what you want to know. Because as you go through the technical stuff, that first description will kind of show up a little bit more. So now that we framed the problem, I will start figuring out these other questions. Can we consistently reproduce the issue, right? Is this a weird timing bug, or is it like, no, if you always do it this way, you will always cause the problem? I'll also ask, have we found the root cause? So for example, oh yeah, we just added this if null check and it solved the problem. Okay, cool, that's great, it solved the problem, but why is that null getting in there to begin with? Right, difference. So exactly this variable is null, so we had a null check. That's awesome, but I'd much rather have this variable is null because the list of valid items hadn't been populated yet. Okay, so that's the problem. The list of valid items hadn't been populated yet. That's really the bug. And so once we've got the context, we'll start going through the fix. And I will usually take one of two approaches. I'll either take a top-down or bottom-up, depending. Top-down says we start with the big picture, and then we start going through the code at the module class. So maybe it's, okay, well, when the user clicks this button, it goes into this class. This class does these things, which then means we go into this other class. And then so you see from button click all the way down to where the bug manifests. The bottom-up approach is, well, because this happened, because this database constraint failure happened, it actually caused this to break. And because this broke, now this other thing breaks. And now you work your way back up the stack. Either approach will work. It just depends on the nature of the bug that I'm trying to fix at the moment. But the idea here, still, regardless, is that you want to show how these things interact with each other. The other thing I recommend here too, and actually got a shout out for the group here. Have you ever worked on code? You fix the problem and you're like, man, that's a really cool solution. But you're like, this works, but isn't there a better, cleaner, nicer way of solving this problem? Call it out in your code review. I've done that before where I've written some code and said, hey, yeah, this technically works, but this seems really bad. Can someone help me out? Call it out in your code review. Your reviewer will gladly appreciate you calling that out because that helps them focus. But in addition, not only does this help the reviewer help you write better code, this will also help coach you on your code sense, right? On the Yeah, now that I know that this is bad code, I now have techniques on how to fix it. So calling out to your reviewers is a pretty good trick here. Once we've done some walkthrough, I'll do some inspection, right? We'll examine the fix. So you are looking at the code, you are leaving feedback on the work done, ideas for improvement. Remember to use that when, what, and why syntax. Also, shout out the good stuff like, hey, cool use of minimal APIs here, because that's awesome. I've not seen that in practice yet. And as you're reviewing this, right, check that's maintainable, readable, adequate quality, follows correct style, all of these things. Then verification, right? Did we actually solve the problem? So we'll demonstrate the fix using the repro steps from before. Awesome bonus points if you actually had a unit test or some other automation that failed because the bug exists. I always love seeing a PR that introduces tests that if I were to run the test without the fix, they fail, but with the fix, they pass. It's such a good feeling, right? Because that's now essentially saying we're not going to have this problem again in the future. Or if so, it's going to be a really interesting way of manifesting. Also, it's at this verification step as you're thinking about things that you might discover other workflows that are impacted. So in the example we had, right, where I'm adding an item to an order and sometimes it fails. Well, what if that add item to order is something that's used in other contexts, like other scenarios? Are those now also impacted? You can figure that. You may not have discovered it at the UI level. You will totally discover it here when you're doing the verification and seeing how the code flows. So, goodness, we have covered a lot in this time on code reviews. So let's go ahead and wrap up a little bit, right? So we talked about why code reviews are important, not only as a professional to your industry, but as a fellow engineer to others, right? Kind of helps you out both company-wise and for your career. We talked about some anti-patterns, right? Too large of PRs or pull requests, not great feedback, missing feedback altogether, not framing the context, not sharing that knowledge with your fellow engineers, all those common anti-patterns. So we talked about those and how to resolve that. We talked a little bit about specifically what I look for in a code review, and we even covered at a high level how I perform a code review. So with that being said, that kind of it for today. Anything that we've talked about today, blog post, books, slide deck, everything can actually be found at this URL posted in on screen right now and also in the chat. But otherwise, that's all I had for you all today. I appreciate y'all letting me come out to Philly Code Camp 2022, and I'll be sticking around to answer some questions if you all have any. Thanks.
I did have a question for you.
Yeah, sure. What you got?
So when's the best time to do code review? I've had experience of it being done all over the place, right? As soon as they're done coding and do their unit testing, or after the user acceptance testing and you're going to QA. I've actually done one and they said it was already in production. So like, when is the best time to do this?
Sooner rather than later. So personally speaking, I like to get the code reviews in before the changes even get merged into trunk or into the main branch. The other piece of advice I'll give is, let's say that there's a lot of code that needs to be reviewed. No one's saying that it can't be reviewed ahead of time. And one of the resources you'll find linked is the concept of a 30% code review, where you start reviewing things about a third of the way through. So you can say like, okay, here's roughly the shape, here's roughly the approach, those types of things. But honestly, sooner rather than later. And the reason being is because going back to that chart, right? The later you do that code review, the later you do the inspection and you find something, do we fix it? Do we not? Okay, we fix it and we have to restart. It can get a little bit hairy there. So my recommendation is pretty much at dev time.
Okay, thanks.
You got it. Thank you, Nicole. Any other questions?
Any tips for people who have teams that are in geographically diverse, like you're in different time zones and it's difficult to actually do this synchronously where we can both get on the same call or something like that?
Yeah, sure. So a couple things that you can do. is, I don't know your tooling, but for what I've used in the past, leaving comments actually on the pull request will help. If you're needing a walkthrough, actually have that person record a walkthrough. If you're using Visual Studio Code, there's actually a really cool plugin I advocate using called Code Tours. And what Code Tours allows you to do is it allows an engineer to add essentially some comments in a Code Tours file, and then you can play it back through, and it'll actually walk you through a code base. It's a free extension, very easy to get started with. I've actually used that before on more complicated code reviews and PRs. Highly recommend it. But if they don't have that, oh, sorry, I didn't mean to cut you off there. But if they don't have that, actually have them do a video recording of them stepping it through can be helpful as well. Pictures, diagrams, anything like that. And when you're talking about different time zones, are we talking about West Coast versus East Coast, or are we talking more like we don't have overlap at all?
Yeah, I'm asleep when they're awake and vice versa.
Yeah, gotcha. So in that case, the thing I would advocate for is to get that team to be leveled up enough that they can be self-sufficient in their reviews.
Well, I think that's depending on the organization, I think that could be a culture question, whether or not there's a desire there to work on that.
Sure, right. Once again, I don't know all your details, but so assuming that there isn't, right, that there's no appetite for that, then the next thing I would have them do is they do their own internal code review, but before it gets merged in, that's when you would do your final. And what you would hope to coach them up a little bit on is that they kind of fix the piddlier stuff, right? Like the obvious things that would be broken or incorrect. And so by the time it gets to you, it's probably 80% good. Mm-hmm. Right. So you're able to focus on the bigger, like, okay, yes, this technically works, but there's like these huge edge cases that maybe you missed. Mm-hmm. Right. Or like this weird idiosyncratic thing that you didn't know. And that way you're still providing the value that you need, but a lot of the piddlier stuff that could get fixed much faster, they can actually handle internally. I've used that technique before.
Thank you.
Yeah, you got it. Great question.
Hey, Cameron, there's one question here, right? So sometimes, there will be a conflict. And it cannot be avoided. And how to handle that one when this happens? So
when you say conflict, are you talking about a merge conflict, or are you talking about a personality conflict?
Not a merge conflict. It's sometimes it's people skills. That type of things. So sometimes when you're a code reviewer, for example, you encourage other one to do the good things. Also, sometimes you have to persuade, right? It's both encourage and persuade, and then sometimes if you handle that badly, it causes a whole bunch of the people conflicts over there. So when that happens, sometimes you try to avoid, right? You really don't want to do it. Right? Sometimes you have to handle that one. So based on your experience, can you share your experience with us?
Yeah, sure. So in those situations where, let's say that you're dealing with someone where there's a personality conflict, right? Or this person's just not really great at receiving feedback. Sure. Some things you can do is pick your battles, right? First and foremost, don't get hung up on a bad variable name, right? That's not where you want to spend your energy. If the approach isn't great, like, oh yeah, the way you're wanting to solve this problem doesn't work for these reasons, be very clear and direct about why that's not going to work. And do your best to keep judgment out of it, right? Because it's not that person who wrote bad code. It's like, yeah, this approach just doesn't work, and here's why. Do your best to keep emotions out of it. But if the other person just isn't really great at receiving feedback, typically what I've done is used my team leader as someone who helps set that quality standard. I'm lucky right now that I am a team lead, so I help set those standards. So I actually coach my engineers on how to talk to one another appropriately, and what's good behavior and what's not good behavior.
Thank you.
Yeah, I know that's probably not the answer you're looking for, but
that's great, right? So at least that's the we're kind of doing the same thing here, but somehow when you set up the principles, right, rules, you have to it's hard to follow, right? It's tough, but I really appreciate your experience and suggestions here.
can I go a little bit deeper on that with you real quick? One thing I have found to be helpful is having a team charter, team agreement. And we actually talk about what do code reviews look like, right? And one of the things I stress with my team is we ask questions in good faith, right? It's not to belittle, it's not to troll. It's really because we seek to understand. We want to know what's going on here. And that is a standard we hold each other accountable to. So because of that, then the team actually starts policing themselves a little bit, right? So maybe I'm not perfect, right? Maybe I leave a really harsh comment on a PR and it just didn't occur. It didn't seem like that to me. That person's well within the right, and so are the other members of my team to tell me, hey, Cameron, that wasn't cool. So we talk about it. I apologize, right? Because I'm in the wrong. And we go from there. And then you just see if it's a pattern.
Gotcha.
Oh, yeah.
Great. Good stuff.
Yeah, you got it. Thank you for the question. I appreciate it.
Yep.
Any other questions? Okay, I'm not hearing any. I don't hear anybody coming off mute. I'm not seeing anything in the chat. If that's the case, y'all, I appreciate everything. Appreciate being here. And hopefully catch y'all next time. Thanks.